So real quick, I want to review the last. We cut off about here yesterday. We had just a little bit of 6.4 to go, and then we'll go work on this stuff. Now remember what we said in 6.4. This is where we're taking, in 6.2 and 6.3 we talked about parallelograms, properties of parallelograms, and there's lots of stuff to work with there. In 6.4 we're looking at some cases of special parallelograms, in particular this stuff, right? We're looking at special parallelograms called rhombuses or rectangles, and then the overlap of both of those would be squares, right? Rhombuses being the parallelograms that have what true?
All sides.
All sides are congruent. Rectangles being special parallelograms with what characteristic?
All 90 degrees.
All angles are 90 degrees. All right angles, good. And then squares have both. In addition to that, so when we split off into these special parallelograms, we get some additional stuff that we know. We know some things about the diagonals primarily. We know that if the diagonals are perpendicular to each other, then we've got a rhombus. That's a characteristic of a rhombus. If the diagonals bisect opposite angles, right, so they're cutting these opposite angles in half, that's a rhombus. Okay? If the diagonals are congruent, it's a rectangle. If the diagonals both have the same length, it's a rectangle. Okay? And I think we didn't quite get to this, so let's quickly look at an example where we could prove, for example, that if we're given a rhombus, the diagonals are perpendicular to each other. Okay, let's quickly just zip through a proof like that. Now, how might this work? We know that we're given that it's a rhombus. Okay. So then we know by definition. What else are we given here? A, B, and okay. So we know by definition that the opposite sides are congruent, right? Okay. So how could we show that these diagonals have to be perpendicular? Suppose any suggestions?
It's a rhombus of all 90 degrees.
Well, I don't think we're allowed to use that. Okay. No. We don't need that though. Okay. A rhombus is a parallelogram. They remind you, right? So all the stuff we know about parallelograms is still going to work, right? So what do we know about the diagonals of any parallelogram? No, diagonals. What's true of the diagonals of any parallelogram? From 6.2, 6.3 stuff.
They're the same length?
No, that would be a rectangle, right? That's this new stuff. But just for any parallelogram, yeah, bisect each other, sure. Right? So we ought to be able to say this thing. We ought to be able to say that those are congruent and those are congruent, right? Does that make sense? Okay, and that's just by the fact that if a parallelogram, then diagonals bisect each other, right? So we get all that stuff, okay? dx and dx and ax and cx, okay? And we would have written that a little differently. All we have to say is if parallelogram, then diagonals bisect each other. Now, look at all those little triangles. What do we see about all those little triangles? Yeah, they're all congruent. I mean, by side, they're all congruent, aren't they? Right? Does that make sense? Okay, so we could then show that the triangles are all congruent. So we're taking, for example, triangle AXB and triangle CXB. We'll just take that top one and that bottom one. Right? They're congruent. And so that means what? By CPCTC, we know that that is congruent to that, right? We also know that's congruent to that, right? Make sense? Okay, and then if we have all four, there's a couple ways we could do this. If we have all four of those angles are congruent, What do they all have to add up to? They have to add up to 360. Or we could even just take two of them, for that matter. We could even take this angle and that angle right there. Those are a linear pair, right? And if they're a linear pair, they add to 180, right? But they're congruent. How could you have two congruent angles that add to 180? It'd have to be 90, wouldn't they? Okay? And so we could get at it that way if we wanted to. Okay? Real quick, we need to take a peek at this. I think we can skip that for now. Skip that. I just want to make sure there's nothing on here. I'm just trying to make sure on the assignment there's nothing that I'm not getting you ready for. Okay. Okay, what about this real quick? I like this. Last one. Okay, you're building a rectangular frame for a theater set. First, you nail 4 pieces of wood together, as shown. What's the shape of that frame? No. Maybe not. I don't agree with that. Not a rhombus for sure, because a rhombus would mean they're all the same. They're all congruent. What is it? Parallelogram is the only thing we can say for sure. How come?
Because it has 4 sides.
Okay, Veronica's on track here. Because opposite sides are congruent, right? 4 sides. Quadrilateral, 4 sides. But we can say it's a parallelogram because of this. Look, 6 and 6, 4 and 4. We measured the wood and they're the same lengths, right? So because we're able to say, now this is kind of an important deal here, because those are congruent and those are congruent, yeah, it's a parallelogram. How come we don't know, just given this stuff right up here, if we look at all that stuff, how come we don't know that it's a rectangle? What don't we know about here? The angles, sure, we don't know that those are right angles. This thing could have been scooted way out of kilter, right? I mean, it looks like a rectangle, but that doesn't mean a thing. Now, let's go down a little further here. To make sure the frame is a rectangle, you measure the diagonals. Okay, if we measure this diagonal right here, we got an answer of 7 feet 4. Okay. If we measure this diagonal right there, we got an answer of 7 feet 2. Okay, so now, is it a rectangle? No. How come? Okay, good, because the diagonals are different. And we just said that if we take the special classification of parallelograms that are rectangles, what's one property that goes with that of the diagonals? Yeah, the diagonals must be congruent, right? Those go together. Congruent diagonals, that's a property of rectangles. If we don't have that, it's not a rectangle. Okay, make sense? Okay, all right. I think we're good to go. If we may have some questions, of course, but that ought to get you going. So now I guess I got to find out where we're headed here.